Hey guys, so this next mini unit is just a few sections and it's on parallel lines and angles. And a lot of it, especially in this first section, you have definitely learned before, I think in maybe middle school. So some of these vocab words may seem familiar, and this first section should be very, very easy. So here we go. Let's get started. Okay, so this section has a lot of definitions. It's on parallel lines and transversals. And so it's a lot of vocab and just like naming things. So it should be pretty straightforward. So first, parallel lines. You've definitely learned about parallel lines before. They are lines that do not intersect and also are on the same plane. So that's the part that is kind of specific to geometry, that they're on the same plane. When you learn about parallel lines in Algebra 1 or like pre-algebra, you usually don't really discuss them being on a plane. So parallel lines in geometry are lines that do not intersect and are on the same plane. This is the symbol for parallel. It's like a miniature little version of parallel lines. I will use it on the bottom to show you how the symbol is used. The next vocab word is skew lines. So skew lines are lines that do not intersect and are not on the same plane. And in the example below, I will show you the difference between parallel and skew. And then parallel planes are planes that will never intersect, just like parallel lines. Okay, so here are the examples that we're going to do for these vocab words. First, it says, name all planes that are parallel to plane ABC. Plane ABC is the one that's already grayed out on the top. So there's actually only one plane that won't touch it. Picture like this is the top of a box. The only side of the box that doesn't touch the top is the bottom. So we would name that plane with 3 letters. So we could say plane EGF or EFG or HFE or HGF, any combination of those 4 points, but only 3 of them, because remember, it's only 3 points to name a plane. Next one is all segments that intersect AB. So here's AB. We want all the ones that intersect it. Remember, intersect just means touch, right? So there are a few different ones that intersect AB. And so let's see, we have AC right here. We have BD right here is intersecting it at A and B. And then we also have these two, AE and BF. So we can list all 4 of those segments. Remember to name a segment. It's 2 capital letters with the bar on top. So we have segment AC, segment BD, segment AC. I already said AC. Whoops. So I have AC, BD, AE, and BF. So that's number 2, intersecting, just they're touching, pretty easy. The next one, name all segments that are parallel to HG. So HG is here. We want parallel, so we want them to be on the same plane, so on the same flat surface. So let's see, we have CD is parallel to HG on that front plane. Do we see how EF is on the same plane as HG? And there actually is one more, and it's AB. Now, right now, they may not be on the same plane, but technically they could be on the same plane. And so what we mean by that is, like, if you can imagine if I were to put a plane from this back of the box, I can show you this in person too when I see you, but from this back of the box to the front of the box, like picture taking like a piece of cardboard and putting it diagonally from the back to the front, then they would be on the same plane. So technically those are considered to be parallel as well. So that's the last one. It's AB. Okay. And then number 4, name all segments that are skew to segment DH. So DH is here. So here's what skew looks like. So we'll never intersect, but not on the same plane. So just real quick, BF, CG, and AE, those will never touch DH, but those are all parallel. So those are not skew. So skew, a lot of times, like CDH is vertical. If you look at ones that are horizontal, that won't touch DH. So like here's one, AB. Do we see how AB is going to keep going on forever back here? DH is going to keep going on forever up here. I know it looks like they're intersecting right here, but they actually are not, because DH is, you have to picture this is 3D. DH is in the front of the box and AB is in the back of the box. So those actually don't touch. Whoops, I did not mean to erase all that. So we have DH, AB is skew to DH. That's the first one. And then anything parallel, well, not anything, but usually something that's parallel to AB would be skewed to it. So EF would also be skewed to DH. Let's see, do we see how AC would be skew? So AC is never going to intersect DH. And also is not on the same plane. And then lastly, EG is the last one. Any other segment is either touching DH or is parallel to DH. So that's those vocab words. Pretty easy. The next part, the next definition rather, is a transversal. A transversal is a line that intersects two or more lines in different points. So if I had two lines here, let's see, say this one was line L, and then I had maybe a line M. And then let's get a different color going on here. So this is two lines. And here is an example of what a transversal would look like. We'll call this one T for transversal. So line T is a transversal to L and M because it connects the two lines. It also intersects the two lines at different points. See how it doesn't intersect them at the same point? An example of something that would not be considered a transversal, like intersecting them at the same point, would be like if I had L, M, and then T transversal. So, I mean, not transversal. So if, say I had this line T, see how it's intersecting L and M at the same point at one point? So this would be an example of something that's not a transversal. And over here, T is a transversal. Okay, so that's those examples. So when you have a transversal, like in this example right here, when you have a transversal, there are 8 angles that are formed, and those 8 angles have special names. So this is what we're going to do next. So first I want to go to and explain exterior and interior angles. These are more like broad, like not as specific as the rest of them. So when I ask you to classify angles, like what angle relationships they have, it's more the other 4. Those are the important ones. But first, in order to do those, we have to understand this part. So exterior angles are angles on the outside of the two lines. So if L and, oh, that did not come out good. If L, okay, well, I don't know why it keeps doing that. If L and M are your two lines, and, oh, there we go. If L and M are your two lines, and T is your transversal, when I say outside the two lines, I mean outside of the transversal. So like these would be exterior because they're on the outside of the two lines. So it would be angle 1, angle 2, angle 7, and angle 8. Those are all considered exterior angles. They're outside the two lines. Interior angles are angles that are in between the two lines. So if you look at this example, again, here are the two lines. It keeps jumping. L and M are the two lines. So interior are ones that are in between them. Like picture like L and M are like a sandwich. Like those are pieces of bread or something. Like 3, 4, 5, and 6 are the meat of the sandwich. And the exterior angles are like the hamburger bun, let's say, if that makes any sense at all. Okay, so our interior angles are angle 3, angle 4, angle 5, and angle 6. So now we're going to learn more specific versions of exterior interior angles, and these are the really important ones. So here's our first one is consecutive interior angles. You may have learned these as same side interior. We don't call them that. The proper name is consecutive interior. They're sometimes referred to as same side interior because they're on the same side of the transversal, and they're also both on the inside. So like if you had 3, I don't know why I said 3 and circled 4. I meant 4. Oh boy, 4 and 6. Angle 4 and angle 6. That'd be one example of consecutive interior. And the other example would be 3 and 5. Those would also be consecutive interior. So same side of the transversal, both on the inside. So that's consecutive interior. Next is alternate exterior. The word alternate tells us that they're on different sides of the transversal. So opposite sides, one's on the left, one's on the right. These are both exterior and they're non-adjacent, so they're not next to each other. So if we look at this picture here, our alternate exterior angles would be like angle 2 and angle 7. They're on different sides of the transversal, both considered exterior angles because they're outside the lines, L and M, and they're on different sides of the transversal. 7's on the left, 2 is on the right, and they're not next to each other. They don't share a side. And then the other example would be 1 and 8. Those are also alternate exterior angles. These coming back to you. These sound familiar, hopefully. Next is alternate interior, very similar to alternate exterior. The only difference is they're both on the inside. They're both interior angles, still on opposite sides of the transversal. So like 3 and 6, those would be alternate interior angles. And then the other pair would be 4 and 5. Different sides of the transversal, not next to each other. If they're next to each other, like 3 and 4, remember that's just a linear pair. So that's not this special angle name. That's alternate interior. And then the last one is corresponding. Corresponding, there's actually 4 pairs of corresponding angles here. So they're on the same side of the transversal. One is interior, one is exterior, but again, non-adjacent. So it wouldn't be like 2 and 4, interior, exterior, same side. Those are just a linear pair. So oops, let's get rid of that. So let's see, some corresponding angles would be 2 and 6. One and 5. There are 2 more. Let's do green. 4 and 8. And then last one, 3 and 7. These are all corresponding angles. They're the same side of the transversal, one inside, one outside. So those are all the vocab words. The last little bit of practice, I'm going to show you some examples of identifying a transversal given 2 angles and also identifying the special name for the angle pair. So identifying a transversal, you want to take a look. This first one says identify the transversal for angle 1 and angle 9. Angle 1 is here, angle 9 is here. So you want to take a look at the lines that form those 2 angles. So see how like this is this side of angle 1, this is the right side of angle 9, and then this line N is in both of the angles. The transversal is the one that's in both of them. That's part of both of them. That sort of connects the 2. So in this case, N would be the transversal. It connects the 2 angles. It helps create both angles. Versus P was just part of angle 1 and Q was just part of angle 9. 9 and 15. See, made by N, L, and then Q is the transversal because that's the one that connects them. It helps to write on the picture. So if you have this picture printed, it helps to like write on it with pencil and then erase. So 4 and 6. So line, transversal. So this one's line P. Uh, 7 and 16. Line, transversal. So line L. Which I did not trace, but that's okay. I tried. 12 and 14, line, transversal, so line Q. So that's how you identify a transversal. You want the line that connects the 2 angles. That's part of both of them. Okay, in the next part, we want the special angle pair. Special name for each angle pair. So these are mostly going to be ones that we just learned today. So 3 and 5, questions you want to ask yourself, are they on the same side of the transversal or different sides of the transversal? These are on the same side. Are they interior or exterior? Well, if you cover this up for just a second, because we don't need that part right now, right? We're kind of focusing on 3 and 5. Here are the 2 lines. P is the transversal. 3 is an exterior angle for M and N. 5 is an interior. So this is same side of the transversal, one inside, one outside. These are considered to be corresponding angles. Okay. Next is 6 and 12. So 6 is here, 12 is here. These are on different sides of the transversal. 6 is on the left, 12 is on the right, and these are both exterior angles. So see how they're on the outside of L and N? So these are different sides of the transversal, both on the outside. So these are alternate exterior angles. I'm just going to abbreviate because I don't have room. So those are alternate exterior. Next is 4 and 8. 4 and 8. So these are different sides of the transversal, but they're both on the inside of M and N. So these are alternate interior angles, 4 and 8. Okay. Next is 2 and 3. 2 and 3 are on the same side of the transversal. And notice how they're both inside. They're in between L and M. So even though 3 was an exterior angle when we were looking at 3 and 5 together, because that was focusing on these two lines, depends on which lines you're looking at. If I'm looking at these two lines, not this one, 3 would be an interior angle because it's in between L and M. So same side of the transversal, both on the inside. These are consecutive, these are consecutive interior. Sorry, my writing is so messy right now. My stylus is kind of starting to not work as well. Next one is 8 and 12. So we have 8 and 12. Same side of the transversal, one inside, one outside. That's corresponding. Okay, 5 and 9. 5, 9. Different sides of the transversal, but both on the inside because they're in between these two. So different sides of the transversal, both interiors, alternate interior. Next is 4 and 10. Ooh, 4 and 10. These are a little different. Hopefully you're all at home right now screaming at your screen that these are vertical angles. These are not one of the ones we learned today. Yes, they're on different sides of the transversal. Yes, one's inside, one's outside. So it's still not corresponding, even though I said for corresponding, not adjacent. These aren't adjacent. They kind of like can't be touching. So, and these are vertical, so they couldn't also be corresponding. So these are vertical. So it's not one of the new ones. Whoa, trying to erase, backfired. Okay, and then the last one, 6 and 7. So what are these? These are different sides of the transversal, both exterior, but they're adjacent. So they're not alternate exterior. What are they? Hopefully you guys all know by now. These are a linear pair. So that's that. Your practice for today is going to be just like this. And this part here, identifying the transversal, and way up here, identifying like parallel and skew and all of that. So please let me know if you have questions. I hope that this is easy. And then next time we'll talk about what happens when the lines are parallel that create these angles and what relationships are true. All right, that's it. Have a great day.